Our topic for today is about how to write the percentage by mass of each element in a certain organic compound. So at the end of this video you will be able to write the percentage by mass of each element in a certain organic compound using elemental quantitative analysis concept. We already discussed what is the difference between elemental quantitative analysis and the elemental qualitative analysis. We said that for the elemental quantitative analysis, it allows the determination of the percentage by mass of each element that make up the organic compound. But how can you determine the percentage by mass of each element in a certain organic compound? Given for you, butanol is an organic compound with the molecular formula C4H10O. If you are asked to determine the percentage by mass of each element in a butanol, and given for you the molar masses for carbon, hydrogen and oxygen in a gram per mole, to determine the percentage by mass of carbon in C4H10O, we will use the following formula. The percentage by mass of carbon is equal to mass of carbon, or the partial mass of carbon, divided by the total mass of this compound times 100. For the mass of carbon, it is equal to the number of carbon atoms, which is 4 here, the molar mass for carbon, while for the total mass of this compound we will consider it that it's equal to the molar mass of this compound. Now we can say that percentage by mass of carbon it's equal to the number of carbon atoms times molar mass divided by molar mass of this compound times 100. Now for the molar mass of C4H10O, it is equal to 4 times the molar mass of carbon, which is 12, plus 10 times the molar mass of hydrogen, which is 1, plus 1 times 16, which is the molar mass of oxygen. So here we have molar mass of butanol, it's equal to 74 gram per mole. So the percentage by mass of carbon it's equal to 4, the number of carbon atoms, which is here the lower subscript for carbon, times the molar mass for carbon, which is 12 gram per mole, divided by the molar mass of this compound, times 100. So it's found to be equal to 64.86%. Now let's calculate the percentage by mass of hydrogen in butanol. The same percentage by mass of hydrogen, it's equal to the partial mass of hydrogen divided by the total mass of this compound times 100. So we will substitute, instead of mass of hydrogen, here we have number of hydrogen atoms times the molar mass of hydrogen divided by the molar mass of butanol times 100. So percent of hydrogen it's found to be equal to 10, which is the number of hydrogen atoms, times the molar mass of hydrogen in a gram per mole divided by the molar mass of butanol times 100, and it's equal to 13.51%. The same for oxygen. To calculate the percentage by mass of oxygen, we can say that percentage by mass of oxygen it's equal to the partial mass of oxygen here divided by the total mass of the compound times 100. We will follow the same pattern, so we can substitute, instead of mass of oxygen, it is equal to the number of oxygen atoms, which is equal to 1 here, times molar mass of oxygen divided by the molar mass of butanol times 100. So it's found to be equal to 21.62%. So for butanol, we can say that percentage by mass of carbon plus the percentage by mass of hydrogen plus the percentage by mass of oxygen, it's equal to 100. So if you have the percentage by mass of carbon and hydrogen, we can deduce directly the percentage by mass of oxygen. So we can say that percentage by mass of oxygen is equal to 100 minus the total percentage by mass of carbon and hydrogen. So in general, if we have the following general molecular formula for a certain organic compound CXHYOZ, we can say that the percentage by mass of carbon, it is equal to the number of carbon atoms here, which is X, times molar mass of carbon, which is equal to 12 gram per mole, divided by the molar mass of this compound that must be calculated, times 100. So the same for hydrogen. Percentage by mass of hydrogen, it's equal to the number of hydrogen, which is equal here to Y, times molar mass of hydrogen divided by the molar mass of this compound, times 100. And finally, the same for oxygen. The percentage by mass of oxygen, it's equal to the number of oxygen atoms, which is equal here to Z, times molar mass of oxygen divided by the molar mass of this compound, times 100. Thanks for watching. See you next time.